Hi, good evening.
Hello,
Oh, good
Roberto.
afternoon. Good afternoon. Sorry.
Hello.
Hello.
Hello, it's 1 o'clock and we got a few people in here. We're going to give them a few more minutes, see if there's a few more that show up. Only got 6 in here right now. Hanging loose. Okay, I'm going to go ahead and get started. Our numbers are dwindling. We've got too many people getting jobs and getting out there and working. So today's lesson is actually pretty lightweight. For this class, we've been doing some heavy stuff with our thermal calculators, but what we got going on this week is our midterm exam. That's actually, it's time for that because we're getting into week 4. So that's one reason why we're having a pretty easy lesson today, because there you can see your midterm module is available. Let's make sure that's actually available. Term pre-test. I know you just feel like you just took your midterm pre-test. Yep, module 6 and midterm. Okay, so that's where we're at on what's available and what we're going to do. So if you were to go back to home, what that means is here we are getting ready to start in module 6. Now module 5 is a project that we're doing together on Wednesday. So we were going to do it last Wednesday, and then we had the big snowstorm. So we'll just get back and into the class and we'll just continue on with what we were doing there. So we want to make sure that you guys come on Wednesday to get your full credit for attendance. And we also have a lesson today that is pretty easy to go over together, and it covers a lot of the same stuff. So before I jump into it, I just want to talk about what we're doing. Why are we learning what we're learning? So we are learning from the beginning about a lot about heat loss, heat gain issues, because when we're getting into a smart home, the idea of a smart home is that we are able to call it an energy efficient home. It's very leaky and it's got lots of problems, a lot of heat loss or heat gain, then it's not considered very smart. It's got issues. We've also had to learn how to calculate some of those issues, such as conductive heat losses, which we've learned is through just the walls and the ceilings and the floors. We've learned that is how that works. And we've learned that we can put different types of materials in the walls that will help us create an insulating barrier. And there's a variety of those out there that we've looked at. We've talked about the diminishing returns of insulation and how insulation is only so good to such a point. If you don't have any, then you really need it. But once you've got a decent amount, it really depends on how cold it's getting where you live, on how much insulation you need, because more won't really help out at that point. So you try to maximize what you've got. Then we've done quite a few calculations on how to do those heat loss, heat gains, and we understand that those losses are in BTUs, and we can contribute that, or we can convert that into watts in our minds as we move forward. Then we started to look at the electrical loads when we got into conducting a home energy audit. We were looking at electrical loads, which is what goes along with our project too. So we want to look at what inside the building is using energy. Do you have any energy hogs? Because it's not all about the losses that we get through the walls when it comes to energy. That is for heating and air conditioning spaces. That's one area of energy, but we're looking at all of them in this class. And so now we know what it takes to insulate a house properly. We know how to calculate those losses. We still have yet to learn how to do our energy audit at home at the Energy Center, but we will, and we'll take some time to do a lot of what we're going to learn today. Because what this is doing is setting us up for the next 4 weeks, where we're going to look at green home building and different types of materials for green homes. And we'll look at home automation systems that go into smart homes. And we'll look at ways that we can monitor our energy usage patterns better, and ultimately get control as much as possible of how much energy we're losing and how much energy we need to make to overcome those losses by understanding our behavior patterns, understanding the loads that we have in the building and how often they're used, understanding the type of building that we have and our conducting heat losses, and as well as our air infiltration, from blower door testing to air infiltration. And that's going to allow us to get into our last project, which will be an opportunity for you guys to work on a dream home, a smart home, where you can kind of think about the type of house that you would like to have or build, and give you a better idea of, if I were to build this house and I were to do it this way, what are the consequences? You know, is this a good type of home to build? Some of these green homes, they try to make them out of recycled material, pop bottles, tires. You have to ask yourself, do you really, if it doesn't cost you anything to build the home, that's one thing. But if it costs you money to do that, you know, is your home going to be valuable to anyone else? So there's some things to consider there when we start getting into looking at green home building and more into the smart home side of it, where we have home automation versus passive type home, a solar passive home, or we have solar energy with electric cars, and you know, things like what we see on this picture right here. That's what we would call a smart home. And there are a lot of things about this house that can be considered smart or not smart. This looks like this is a solar passive house with windows probably facing the southern hemisphere. And then it's got solar here and there, which doesn't make much sense. So maybe this is facing the south. We don't know. But those are all types of things that we have to think about when we're designing a home. So now we've got a better idea of what happens in older homes and different types of homes when they lose energy. For your midterm, what you want to make sure you've done is all of this. Okay, the projects are separate. You did have some thermal calculator stuff on your midterm. I took it off. I think it's just too hard. And then we didn't get a chance to go over it last week. And I want a lot of you are in more than one class with me. I don't like giving you midterms all at the same time. So we're going to go ahead and move forward with our midterm in this class. And that's just going to cover weeks 1 through 4, everything that you've seen, including today's lesson, and assignments 1 through 4. So as long as you've done 1 through 4 on your assignments, and you feel good about all this information, and you've done your homework, you should be just fine, and you'll have no problem taking your midterm, because the material is just your homework in most cases on a test. So that should be easy enough for you. If you haven't done your homework, make sure you get that done before you try to take this midterm exam. Okay, you have some time. So that's not due until I think the 14th. I can take a look at that of February. That's not the right one. Let's just go back. No, I don't want to leave the site. I don't know what it's doing there. Yeah, we want to leave that. There we go. Okay. I got a few more people in here. Let me check our attendance here. Ben, Jessica. Josh. Okay, guys. Very good. So what you need to worry about for this class is just try to get caught up on your homework, which includes today's lesson. We'll go over this fairly quickly. That'll give you a chance to work on some of this stuff if you haven't got it done yet. Still want to take your midterm pre-test, which covers just weeks 1 and 2. That's going to help prepare you much better for taking your exam. The exams are timed, so you don't get multiple attempts on them. As long as you've done all your work, you should be just fine. Is there any questions or comments for me before I get started? Okay. We're not in module 4. Let's get into module 6. That's where we're supposed to be. There we go. So not a whole lot in here. Again, we got that test. So we're going to cover this e-textbook. It's chapter 5 in a book called Smart Grid Home. And we've used it a couple times already. And it's a really good exam. I like the book because, you know, some of the books is all formulas and all stuff and math that we've experienced. It's not enough. How do you do it? This is a little bit more of how do you do it? What are some of the ways that you would do this? And as we go through this information, what you want to think about is on Wednesday, when we start doing our energy audits at the Energy Center, I want you looking for this type of stuff. There are jobs that you can get out of school. I've got several people that have graduated that work in energy auditing, and it's stuff that they've learned from this class mostly. And so some of the companies that you could look into are TSI Solutions, which is around here. They hire people, and Clear Result. Clear Result is another one that hires people for energy efficiency and energy auditing. So those are some things to think about. There's been quite a few of you guys that have gone down that path and are still working in that industry. You've got your homework that goes over module 6, and then they do talk about Windows a lot, and there's not enough pictures, so you have a quick link in here on Windows. Let's take a look at that link here. There's your homework, and it's due February 14th. Types of windows. So we don't need to hang out on this site for very long. This is just a reference here because they do mention windows many times and different types of windows. So if you're not sure what type of window, here you go. They show you pictures. So double hung vinyl windows. Some of these are just fancy windows like arch windows. Awning windows, those are specific. Bay windows, bow windows. Lots of different types of windows. some of the things, that's a garden window. Some of the things that you want to look for are storm windows. So you've got picture windows, very large windows. I have picture windows, very expensive, big, and terribly inefficient. Sometimes I wish I didn't have them. Skylight windows, those can be used to help bring light in or possibly add heat, passive solar. Sliding windows. There we are. I was looking for storm windows. They talk about storm windows a lot. So those are windows that I think a lot of the homes around here have. We have storm windows. And so you'll see that they are usually double or triple pane, or they have an outside window that goes on the outside, kind of like a storm door that you can remove or put in. So those are in places that have high winds, lots of storms, tornadoes, which we do. So those are good windows to have. Okay. So that's all that link is. And we'll go back. And we'll go ahead and get started. So what you want to think about when we go through this are some of the things that you might need to do on your own home. In this class, we've done energy audits on the Energy Center before, which is kind of limited, and I've tried you guys doing energy audits on your own homes at home. That depends if you've got a home, so that one's a little harder to do, but I would encourage you to one day just well, especially after Wednesday, you might feel a little inspired to do a little bit of upgrading your home and energy efficiency in the building that you're in, especially right now where everything is cold. You might borrow one of our thermal detectors, and those aren't very expensive, not the real expensive one, but we've got some basic thermal detectors that you can take home with you and look around. They're pretty fun. Once you start, you'll see what they are, but you'll be able to identify a lot of cold spots, things that you had no idea that were creating such a problem for you. So we need to determine air leaks inside and outside of the home, determine the existing insulation is adequate, install extra insulation, and rate home windows, doors, and skylights. So another thing to do is if you're trying to find some activity to do, you might, and you need to get out of the house, you might just take, after you go through some of the stuff in class, you might just go to the hardware store if you got time to kill, and go ahead and start looking at like their doors, the R value of their doors. Take some time and look at the insulation that they have. How much does it cost now? What are the R values, the different types? Look at their windows. That can be a good activity for you when you're just out and about doing your normal daily errands. Okay. So the first thing that we need to think about is ceiling leaks. And they talk about sealing the outside leaks first. So those leaks can get into the wall cavities. So there's different ways of doing that. When you go to the Energy Center, you should go outside and take pictures of anything that looks like this, where you've got a penetration into the building and it's poorly sealed. So this is usually going to be from air conditioners. If you've got an air conditioner, which most people do, they always have a wall penetration, and they can, and at one time may have been sealed, but now it's deteriorated, hardened, or shrunk. And so you'll want to caulk those back up or put a duct seal type putty around that, which can help, but these are outside leaks. So you also want to look for exterior brick corners, outside brick corners that have cracks. Same thing with exterior siding. You want to look at the siding and see, is there any siding that is hanging on the house in a very loose fashion? Is it tucked in nice and tight? Is it flush? Or is air blowing around the siding and getting into the house through an outside leak? Here you can see the windows of this particular situation. It's so bad that the cracks around it are too thick to fill with caulking. So the reading talks about you can fix your windows really well if you fill that up with foam or insulation or a different type of filler and then go back over it with caulking. A brand new window would be better, but not all of us can afford brand new windows. So this is one solution that can drastically reduce your heat transfer. As we watched in some of the videos, joints where siding and chimneys meet, we won't have any chimneys, but you'll be able to find joints in a lot of different places where there's cracks, and you'll be able to take your hand and feel the air blowing. Window casings where they join the brick or siding, just like we looked at there. Make sure those cracks are filled. Door casings, doors are a big one. Make sure you're looking at the way the door is sitting. Is it flush? Is it square? Is the frame rigidly set in place? Does it need caulking on the frame? Doors are a terrible place for, just like fireplaces, where you lose an enormous amount of heat or you get a lot of air infiltration from. The next area you want to look at is an area that is not really often thought much about, is where the foundation is. Down below at the ground level, do you see any of the insulation on the lower edge of the building pulled out away? Do you see on your foundation, do you see big cracks like this that are obviously old caulk and UV lighting and everything has taken its toll on it? That would need to be recaulked because the air is going to blow right through that and go into the walls and find its way into the house. So when we talk about looking at the edge of your siding, you're talking about using something called a wood stringer. A wood stringer is a piece of wood that fits flush underneath your vinyl siding and your foundation, and will have a nice bead of caulk that'll run along there. You'll find that many houses right underneath here is wide open, and there's the drywall. You can almost like stick your finger up in there and touch the drywall. So any air blowing this way right up in there is going to make all of these corners of the house very cold. So you want to plug those. You can use a foam insulation to plug some of that, but they recommend using a thing called a wood stringer. Any questions or comments so far? Has anybody got anything in their own house that you can think of that's really bad? You got an example of it that you might want to share? So if you don't know, that means you probably haven't looked. So it's a good time to look as we're learning. I know my front door is terrible, and one year I just taped it shut, and it did make a big difference in how much heat loss, but then I can't go in and out of my door. but it needs to be reframed. Once you've sealed all the outside leaks, then you need to look for inside leaks, places inside the building where you've got holes, such as water pipes passing through this wall here. When you guys get to the energy center, there's a little secret that most of you guys don't know down in the basement, and I'm going to see if you guys can figure it out. There's more of that building there than what you can see. So there's a couple interesting places that you're going to want to explore and go, whoa, look at that. I didn't know that was there. Crawl spaces. It's an odd building, and it creates a lot of problems. And it's got a lot of good examples of things that you would want to fix. So same as the outside, sealing with a duct seal, type putty, or caulking. It's going to depend if you can get to the leak as well, whether or not you've got to open up the door, open up the wall, I mean, to get in there and fix those leaks. If you have a wall that's extremely cold, you might be able to go through an electrical outlet or a switch plate to try to see if you can't fill the wall with some insulation, or, as we've learned, put some gaskets around those electrical outlets, those switch plates. Those are on the inside of the building. So you want to look for those. On the inside of the building, you want to look at the window frames from the inside. How do they look on the inside? Do they need weather stripping? Do they need caulking? Looking at your exterior wall baseboards. Remove the baseboards if you can, and look and see if there's any air infiltration right along the base there, where you can either run caulking or put some type of insulation in there, small insulation. Most likely you're just going to try to seal it with caulking. Weather stripping around the doors. You look at the energy center, the doors are pretty old. They're not well square, and the weather stripping is gone bye-bye. We've got some new weather stripping that we can look at. Maybe we'll install some of it, maybe we won't. I don't do too much of that anymore on the energy center without talking to maintenance first. But what we can do is find areas for them to maybe consider fixing or letting us fix. Fireplace dampers, attic hatches. As you notice, our attic hatch was sealed in the energy center. It had an insulated zipper type hatch opening. I can't remember what we call that, but you can put styrofoam over the top of an attic hatch, or you can use more or less type of specially made attic hatch material that can zip or unzip as you go in. Wall or window mounted air conditioners. Make sure, I mean, those are going to be terrible. They shouldn't be in there in the winter time, but in the summertime, you've got to deal with heat infiltration from the hot air. So you want to make sure those are all sealed very good with plywood and fiberboard or caulk. Depends how you do it. You know, they're hard to seal. Okay. If the home has an unheated basement or crawl space, these should be treated as outside exposures and the floors above them sealed to prevent air leakage. Most openings can be more easily sealed from below than from inside the house, but every opening should be made airtight as possible. Okay, there was a key here. Insulation added to the floors of a home, especially in below grade basements. So if you have a below grade basement or a crawl space, should not be sprayed foam, as this type will trap moisture against the floor joists and flooring, causing rot to develop in both cases. So the best way to block heat transfer through floors above basements or crawl spaces is to seal the lower level airtight, add insulation if you can, and it should be some type of styrofoam. So I thought that was an important key to think about, because you might crawl under your house and spray foam it, and they're recommending not to do that because it can cause wood rot. In underground locations where there's a lot of moisture. Next is to determine if you need insulation. So as we've learned, you can look in the walls with thermal radiation, not thermal radiation, but infrared thermal radiation, and see inside the walls, inside the cavities, where the insulation is. We'll have that opportunity when we go to the Energy Center this week. We do have the thermal camera. It's there waiting for us. So as soon as we get a chance, we'll get to play with that. Everybody will get a chance to play with that and look around. Something the book talks about here is, and it's smart, is to check whether your state government has any weatherization or energy efficiency programs. So there's a couple websites that you can go to. We'll learn about those in another class, but you can follow their advice here. They tell you where to look, but there's some websites that have everything all in one place, nice and neat. But you want to be able to try to get a tax credit for any of the home upgrades that you do. So some of the state programs, then there can be government programs that work with the utility. So you'll have a utility that will offer a rebate if you put in, say, a new furnace or new insulation. And those are government programs, but you get them through utility. So you want to call your utility to find out what type of incentive programs for upgrading your house, such as increasing your insulation or possibly putting in new energy efficient furnaces or water heaters. And of course, there's tax credits for renewable energy as well, whether you realize that or not. So if you're putting a solar system in your house, solar thermal, you can get tax credits and get a certain amount of back off of that. It used to be you could get 30% back. So if you spent $10,000, you get $3,000 back on your taxes, which was a pretty nice program they had. So the programs are always changing. Here they're talking about installing insulation, blown insulation. So their prices are a little bit old. Everything's gone up. We know that inflation's crazy right now. So whatever the price is, you can look online, get on the Menards website, get on the Lowe's website, look it up pretty easy, find out what the cost of insulation is. But when we're dealing with fiberglass or bad insulation, you want to wear a mask because you can get irritation from the particles. You want to wear long sleeve shirt and gloves because those things can be itchy. They got little bits of fiberglass that float around in the air, and you breathe them in and you get them on your skin. It's not comfortable. So there we go. Blowing insulation. There you see he's got a gauge there so they know when they've reached a certain level, and you move that gauge around. And also you can't see, but you can't stand. You got to make sure you're standing on these joists. You'll have possibly let's see, like right here, put down some wood while you say roll out your insulation, because you can't squish insulation. Insulation like this works off of the idea that you have air pockets in here, and if you squish insulation down, you don't have air pockets. So it's really just air that's blocking airflow. So air will not, is a gas. So once we have a nice warm blanket over the top of us, it's much harder for that air to penetrate through there. So most of the air gets blocked and floats away. You want to check your insulation for dark spots. We learned about that, where we can see moisture, stains, even mold. You want to make sure that you don't cover bats around. Well, you want to get them nice and snug around your wood, or you want to be careful when you put them around your electrical boxes, particularly. So you got to cut the insulation so you can have access to those electrical boxes and your air vents, things like that. You don't want to cover with insulation in your attic vents. Okay, so they call that the split and tuck technique. There we go, and we see some nasty insulation there that needs cleaned up and removed, and then there's most likely needs to caulk and seal that area. This is just telling you the method that we did look at. Some of us may not have seen it, but when we were in the Energy Center, we were in the conference room and we looked at one wall that had no insulation in it, and we felt the hole that we cut into it. It was very cold air blowing through there, as an example of what is going on from an air infiltration point. And then we had one wall that was right next to it where we insulated the cavity, and that wall you couldn't feel the air blowing through. So this is just telling you to locate the studs, cut a hole, then you can go to a hardware store and rent a blower and blow the insulation into the walls. And then you just need to go back and drywall the cutouts back in. So all that can be done pretty easily, actually. Energy efficient windows. So we looked at different types of windows. There's a couple things that we've already learned about windows that they reiterate. One is the U factor. We know we can take the reciprocal of the U factor to find out what the actual R value is of a window. But we also know that windows are rated. So they're rated in a solar heat gain coefficient, SHGC. The lower the SHGC, the less solar heat the glass panel transmits. Another method of describing windows is the emissivity, or the E value. This can be a little confusing. So what we want to know is if the E value is closer to 0, then that means the material doesn't absorb any radiation, but reflects it 100% of the energy that strikes it. And if it's close to 1, it's a perfectly black material that absorbs 100% of the energy that strikes it and then emits it back again as heat. So it depends on what type of situation you want. You may want one depending on where you live versus the other. Do you want sunlight coming in through your windows, or do you want to reflect that back? So what we're talking about is different types of material. Like brick is closer to 1. That means it's going to absorb a lot of the heat and re-emit it. We can look at some of these other things. If they're closer to 0, then it's less likely to absorb and emit it as heat. You can put a reflective coating on your windows. So what we're talking about is this type of reflecting coating. So if we want solar radiation to go through the window, then we can have a window that has no reflective coating on it, no solar guard film. I think our library on campus has solar guard film on all of its windows if you want to see a building that is utilizing it. And so that means the sun shines in. If you let it pass through, it's going to warm the house. If you want it to reflect, then that would be, you don't want heat coming into the building because it's more of an air conditioned space, and that's what you're more concerned about. So you can get different levels of solar guard film. Up here, they just talk about the R values of windows. So single pane glass windows have an R value of just 0.91. But let's look when we get into double pane, when they have a 1/4 inch airspace between the panes. There you're going from 0.91 to 1.69. That's a lot for a window, but it's still not a very high R value. You can get into very more expensive triple pane windows. You notice their R value is only 2.56. And then widening the airspace between the panes, that's how you're going to increase. So you got to have a thicker and thicker window to increase it. So when you're looking at windows, it'd be great to get the best windows that you can, but windows are going to be always a low R value and an area of concern. You can do things like put a glass coating to increase the R value of the glass. That's something that can be done. You can put awnings out to try to block some of the sun, shades, a variety of things that we probably already do. Let's move on down. And the problem with replacing all your windows is they're expensive. And if you do replace them, you would want to make sure that you got a big bang for your buck. So if you happen to spend your life savings, I wouldn't spend them probably on windows until you've got enough money, just because they don't add the R value. Now they do talk about storm windows. Storm windows are nice because they can raise the value of a single pane window to about 2. You can take those in and out and add those. So storm windows are pretty common, and they create that multi-pane, and they're pretty easy to install. Talking about different window frames, plastic plane window frames, vinyl frames are probably the best, but over time they're still going to deteriorate. If you have window frames made of wood, aluminum, or vinyl, they're going to be more maintenance free if they're aluminum, but you've got to deal with the reflectivity of it, and over time, aluminum, well, we know holds heat, so it's going to be, they're going to get very hot in the sunlight, and that's why vinyl windows are the most common ones that we see. If you have wood, the wood insulates well, but weathers with age. That's something I'm dealing with. All my windows are wood, and I need to recaulk them. I need to replace some of the wood. So it doesn't matter what you choose. If you have vinyl, they're basically PVC, and they're going to be able to last probably the longest of all, but they will degrade just like all other windows, especially around the windows, the weather stripping. You got to seal them up and make sure that you're not getting any outside air infiltration. Any questions or comments? Okay, 148. Energy efficient doors. Most doors are going to be between an R value of 2. So if you have wood doors, you have about an R value of 2. If they're hollow core and they have some insulation, you can get your metal doors to get closer to maybe an R value of 5 or 6. Sliding glass doors, we know, are going to be poor insulators, and there's going to be a lot of leaks around those. So fancy doors, just like big windows, are going to be problem areas for you. Do you really want them? And do you want to do the maintenance to make sure they stay in tip-top shape? The trick with doors is if you need to put a new door in, you're going to need a new frame. A lot of times the door that you buy won't fit in the frame that you have very well. If it's a really good frame and the doors are an exact match, then you can go ahead and do that. But it may be a little more difficult. That's where weatherization and weather stripping may be a better option for you than replacing an entire door. Energy efficiency skylights. So we know that those can produce a nice warm sunlight or light, give you heat or give you a light source. In the summer, every square yard of a building surface area is being bombarded with the equivalent of about 1,500 watts of heat and light energy. That's a bit of a stretch of a statement. That would be more like 1,000 watts of heat and light energy, in my opinion, and it would be only on the sunniest of days. Another option that you can do are awnings or shades. So there's an example of a shade. That one's designed to help deal with these large windows near a swimming pool and the reflection of the sun into the windows. This large shade helps block the sunlight shining in. They talk about some of the different materials. If you have like plastic awnings and things, that they're gonna, over time, they're gonna degrade. So there's not much you can do about that. Landscaping. Direct sunlight, it's going to shine into your house. One of the best things you can do is create shade, lots of trees. So deciduous trees are natural sun blockers. Really all you need to understand is bushes and trees. You can see how much shade you can get from those once you, if you've got enough trees. If you, they take a long time to grow is the problem. There's another thing called wind breaks. So if you can't get trees to grow, you can put in shrubs or bushes or little fences in that can help create a windbreak and try to reduce some of the straight line winds. And that's going to be the same thing you can do if you have a fence. So fences, bushes, outbuildings. Yep. Okay, that's it. That basically wraps us up. So what you want to do is just think about all the stuff that we've learned so far and think about what kind of house you would want, because we're going to talk about that. What kind of building would you want? Here are your glossary items in here. I would take time when you read these books. It's always good to go back and read the definitions before you do your homework, because you can find a lot of the answers to some of your homework in some of these definitions, so you're not lost in the book. Okay, that's all that I have for today. Just give you time to work on your homework, and then get all that caught up, and then get ready to take your midterm exam. We want to try to get that done by next week, because that's time for me to post midterm grades. So good luck with that. Are there any questions for me before I let you guys go? Okay, well, that's all I have for today. I'll see some of you guys tomorrow night in tomorrow night's class. And if I don't see you then I will definitely see you on Wednesday. And think about all this stuff. If you've got an iPhone or an Android phone with a camera, it'd be good to bring it so you can take pictures of some of the things that you find in the activities that we're doing. Okay. Well, have a good rest of your day and good luck on your test, and I'll see you guys later.
Thanks, John.
Yep.
Bye.
Bye-bye.